Welcome to our talk on testing GraphQL APIs. In this talk, we walk through different ways of testing to build rock-solid GraphQL services. At first, we'll introduce ourselves. Then, I will go over our lessons learned and experience of running GraphQL in production, serving billions of requests. After this, Julian will go over examples for different test types and explain concepts. I'm Bruno. I'm a backend engineer at GraphCMS and also a student at the Technical University of Munich. In my free time, I write blog posts about everything I'm curious about.
Hey, hello. I'm Julian. I'm a full stack engineer at GraphCMS. This is not a pink sweater. This is a GraphQL sweater. And that's what I do all my free time and my day-to-day job. I build GraphQL tools such as GraphQL admin, GraphQL UI builder, and I see a GraphQL barb generator over there. You can ignore that part. I didn't really build that. I'm not sure how that works. And you can check more at my site. Okay, Julian. And now we can continue with Bruno and start the actual talk.
So let's start with the lessons we learned testing our GraphQL services. Throughout the next section, I'll focus mostly on the backend side of things. And whenever I talk about different test types, it's important to note that your team might have different definitions and conventions. So I'll always explain the scope and purpose of a test as well. Our testing story starts in 2018, when we started to test our GraphQL APIs using end-to-end tests. Back then, we needed to add tests to prevent regressions in the API layer. And for this, we configured our tests in a big JSON file and deployed the service to run periodically, ensuring endpoints would work as expected by sending real GraphQL requests against the production infrastructure. As you can imagine, the configuration format made them hard to write and maintain. So assertions were hard to represent, and it wasn't really nice for us. Debugging was also rather hard, depending on the test case. So we took what we learned and we iterated on the idea. And what we came up with is, it was the same format, but we used TypeScript and added code generation to convert our GraphQL operations to code that would send a request and handle errors. So quite similar, but now it was much easier to write compared to the JSON we had before. But still, debugging would get hard when errors happened deep within the stack. And over time, we added lots of those tests. And that led to very poor performance. Because remember, we're still sending actual HTTP requests for every test case. At the same time, we also wanted to test more parts of the code base and set up integration tests for our backend. We wanted to use the same APIs our customers work with for testing. So similar to our second iteration of end-to-end tests, our backend integration tests use code generation to send real HTTP requests against a local backend setup. Tests were relatively easy to write, but again, the more we added, the more they slowed us down. And you might have noticed that we only tested at the GraphQL layer so far. By now, it seems kind of obvious that the direction of having many expensive tests covering the complete stack is not really feasible. And the performance hits we took were more expensive than the benefits we got. So we made a lot of adjustments, tried around, and reset our assumptions about how we want to test. Let's get started about testing today at GraphCMS. As you might think, the solution to most issues was quite intuitive when you've worked with testing services. So after our experience with the long-running, unreliable tests that made it hard to debug, we switched to using mostly unit tests. For our team, unit tests allow to make sure each piece of code works in isolation. To cover most of our existing code base, we needed to put in work up front to refactor and start writing more testable code, changing our mental models in some parts. Now we try to reduce dependencies where we can, and otherwise we mock services to test each unit in isolation. In the optimal case, we have a pure function that transforms inputs into outputs and has no side effects whatsoever. For sequences of functions and code connecting multiple units, we use component-level testing, which merely asserts that functions are called and connected as expected. Unit tests are incredibly fast and easy to write when the code was written in testing in mind. You might find repetitive test setup and mocking code, though, which you can refactor and reuse. The biggest goal is to enhance your team's productivity and developer experience. The only downsides to unit tests is that incomplete coverage combined with extensive mocking may lead you to some dependencies being untested. So you really have to watch out for those cases. If there's anything to take away from our experience in testing GraphQL services over the years, it's really that you should test on different layers. There's not just GraphQL, but there's also unit tests, integration tests, whatever really works best. And identify the benefits and drawbacks so you can really optimize for what works best for your team. Julian will now take over with examples for the different test types we're using for our GraphQL services.
Yeah, thanks so much, Bruno, for that introduction and for telling our story. We really learned a lot from that. And my job here is to take that down to earth a bit with an example. So for that, we built this query generator API as an example of an API you might be building and you want to test. So let's go over a bit on how does it work, how this example works, and then we'll start checking out how we would write that based on the things we learned at GraphCMS building and testing GraphQL APIs. So first of all, there's a repo with this example, so feel free to check it out and see more of the details on it. But basically, this is a service that allows API consumers to generate GraphQL queries. And I know this is a bit meta and it may be hard to grasp at first, but yes, you will write a simple query against this endpoint with an API URL, and it will generate a complex GraphQL query. So it is basically a GraphQL query generator that you communicate through an API. And let's see a bit what this looks like so it's even more clear. So this next slide has an example UI that you would build with this service in mind. And as you will see shortly, it is an example where you put an API URL, a GraphQL API URL, you click generate, and like magically, it would get all the fields, and you will be able to generate automatically a GraphQL query for every one of those fields without knowing GraphQL. So it's a great tool for beginners and for quickly showing the power of GraphQL API and all automation that you can have on top of them. So let's take a look at the API that would fit this UI. As you can see, now I'm gonna start the server, the API, and let's go to GraphQL Explorer to send an API URL, a top level field, and then see that it generates the correct query and variables to get that information. So as you can see, now it goes to the actual endpoint, in this case, the SpaceX API, and it generated a missions query in this case. So that's a great way of finding out if that worked, to go to the actual GraphQL API. And that's the example, that's how you interact with it. Now let's see a bit how we would test that from an end-to-end layer to an integration point of view, and then finally unit tests. So let's start with the first kind of test that we could write against this kind of API. And it's a very special kind of test because you want to be really close to your users. So you want to run that on a production live API. You want to test hot paths because this is a slow query, a slow type of test. And you would generally do that periodically, like against an endpoint. So you can see it as an uptime of how well your API works. And this is great for preventing regressions. And it really reflects one of the test types that Bruno introduced that we had on our production APIs. So to exemplify that, we built the tool we wish we had when we have those production API testing tools. And it's GraphQL Sonar. And it leverages code generation based on your schema and your real queries that you have on your system. And it gives you, and it provides a great way of applying that on a test. So let's take a look at the code part of it. As you can see, based on your config, which is an endpoint and probably authorization headers, it uses code generation so that you can write a great set of operations to run against your live API. And as you can see in this example, we checked that an API, you can fetch posts. There are no errors. There is exactly one post, and it has content. So it's a great utility that you can use on your live endpoint. So feel free to check it out. Go to a repo, take it for a spin, and please let us know with your feedback how you like it, and we would love for you to test it out, and so we can continue improving it. And now that we introduced that nice little tool for end-to-end test, we can take a look at a layer below, which is HTTP integration tests. As always, naming is hard, but it's always great to keep in mind what type of test are we covering? Is it from the user point of view? Is it not? That would make for a great description, even though you might name this differently. So in this case, we're talking about tests written from the user point of view. They almost don't have any mocks because we want to be as close to end-to-end tests as possible. And just because of that, they have a complex setup because you want to mimic your real APIs as much as possible and interactions. But let's take a look at the code part. These tests are written from the user point of view. In this case, we're building APIs, so a user is an API consumer, an HTTP consumer. So as you can see, this test that checks that the API persists a query to the database, we check that by sending a fetch request to a live instance of our API. Not a live, but you start it with the test. And that's what we mean by complex setup. And we can take a look at that part. As you can see, we have a lot of setups and teardowns of everything the test needs. In this case, we have a mocking layer, just so we're sure that the test is not communicating with the outside world, just so that it's fast and you don't depend on the uptime of external services. We want to start and stop the server, actually, because we want to test it by sending an HTTP request. We want to clean up the database before and after each test. So as you can see, these are complex, and that complexity turns into time and if you multiply that with a lot of tests, you have a slow test setup. So you want to be sure that you're testing only the right parts here. And as you can see, it's best to be as close to the user, so it doesn't have any database mocks, for example. If you want to not depend on the database, you would need to go one level deeper on integration tests. And in this case, we have more technical integration tests, like not from the user point of view. You want some mocks here because you want these tests to be fast, but you also want to test many components. So this makes for a simpler setup than the previous kinds of tests we showed. Let's take a look at the code part of that. As you can see, these are technical, and by that I mean you will be calling functions, internal functions on your API that the users will have no idea that exist. In this case, we have a function that's a resolver. As you can see on the code there, there's a field query. This is the resolver that generates the queries that you asked the API for. And we have a test that checks that that resolver successfully sends a request for a schema to an external service. So as you can see, we're calling functions here. So this is more technical than something that tests from the user point of view. And we do a mocks here. We want to mock out everything that we're not testing for. And as you can see in this case, we're using Jest to create some mocks for some implementation of a function. And that's great for, in this case, testing and being sure that external services are not getting called. And we built another small, little, but very useful tool for handling interactions with external GraphQL APIs. We called it Query Hub. It's live on GitHub. Feel free to download it, take it for a spin, as well as you did with Sonar. And what it does is you define APIs to mock, and it records interactions with those GraphQL services so that you don't need to handle all the mocking manually, like checking what the API responds, storing that in JSON, and then updating that as time goes. Query Hub handles all of that for you. As you can see that in this example, we're using the MSW library and Query Hub to record interactions with an external service and saving that in an introspection.json query. So we're really excited about this tool and take it for a spin, give it some test runs and give us your feedback because it's really valuable for us. And lastly, we want to go to the last level deeper in unit tests. So from the story that Bruno told, we find that unit tests are great for testing really technical parts of your stack. You have probably some functions that have a lot of edge cases and that you want to run really fast and don't depend on anything external. So having a bunch of unit tests to make sure that your functions work correctly or your classes is great. And that's a solution we ended up at GraphCMS after some iteration, because even though they're harder to write than end-to-end tests, they're really fast. And you do want that on your test setup because you want to improve how you evolve tests and you want to run a lot of them. So yeah, unit tests are great. And in this case, in our example, we have a lot of tests that verify that the different complexities of generating GraphQL queries are taken care of. So they are a great tool and you should definitely use them. We use them a lot. And they generally have no mocks, as you might imagine, because you want to test little units. If you do need to mock stuff out, then of course that's great to do, but it's also a good point for you to figure out if maybe this is more of an integration test, or maybe you need to refactor your unit so that it's more testable without mocks. So that's something to always keep in mind. And now Bruno will handle the summary. You're welcome.
We covered a lot today, and we had to cut even more. Testing is really a giant topic, and it's incredibly individual to each team out there. I think the most important takeaways of this talk are that you really should identify the test types that provide the most value for you and your team, and you should optimize for them. And this also implies that you're not restricted to testing at the GraphQL layer just because it's a GraphQL service. You should know that there are different layers you can test on, and you should use the right test types and tools for every layer. While we're talking about tools already, you can mock external requests using Query Hub, and you can use your existing queries to cover hot paths in production services with GraphQL Sonar. We've enclosed some additional resources, such as the links to the tools we introduced today, as well as our slides and the repository containing all examples. Thank you for joining today.
Thanks so much. I'm glad you're listening.